Swayam Prabha. Digital India. Educated India.
So, last class I have discussed about the negative skin friction, and I have discussed the negative skin friction for single pile. So, before I start the example problem, so I should discuss about the negative skin friction for group pile. Okay. So, this is the group pile. So, the negative skin friction cases are same as I have discussed for the single pile. So, only difference is how we can determine the negative skin friction for the group pile. The same way we can determine the negative skin friction for the group pile as we did it for the group pile load carrying capacity. So, first we calculate the negative skin friction for the single pile, then you have to multiply with the number of piles. So, this is the group negative skin friction that we determine the negative skin friction for single pile, and then we multiply it with the number of pile, where is the number of pile, and this is for the negative skin friction for single pile. Okay. So, this is the negative skin friction single pile, and then we can calculate the negative skin friction as a block for the pile group, and that is the expression, and where P A G, again the area will be this is the group pile group, and this is, if this is the S is the spacing, and this is d by 2, this is also d by 2. So, my B will be 2 S plus d for this particular case, and if it is a square pile group, then this will be B square. So, this is B plus 2 S plus d. Okay. And then this will be the, so area will be A G will be this particular case B square, or if it is a rectangular pile, then A G will be equal to B into L, rectangular pile group. So, that means the here A G and the L C is the length of the your negative skin friction zone, and F S is the negative skin friction, and then that negative skin friction F S we can determine the same way that we have discussed for the single pile, because we are doing the same technique, or we have done the same technique for the load carrying capacity of the pile also. So, the same way we can determine, then you have to multiply with the P G is the perimeter, and so perimeter will be here for 2, or P G perimeter of the group will be B plus L for rectangular, or P G will be 4 B for the square. This is for the rectangular, and this is for square. Okay. So, that way we can determine the P G and A G, and L C is the length, and this unit weight is the unit weight within the pile group, or within the pile group up to a depth of L C. So, this way we can determine the negative skin friction for group, and minimum of these maximum of these two, because in load carrying capacity it was minimum of these two values, group block failure and single failure. But here, as the negative skin friction will give us the negative effect, so we have to take the maximum of these two as your negative skin friction for the group during the design. So, this example problem is for, so first we will go for the single pile, then we will go for the group pile. Okay, the single pile, we have that profile. So, suppose this is the pile whose diameter is 0.3, it is uniform cross section, and the field zone is 2.5 meter thick, 2.5 meter thick. So, that means L C is equal to 2.5 meter. So, whose properties, it is a cohesive field, whose phi dash is equal to 30 degree. So, under CD test we have determined that, and the unit weight of the soil is 18 kilonewton per meters cube, and water table is at the top of the field. And we can consider delta value is 2/3 of phi dash, because delta is given 0.5 to 0.9, here we have taken 2/3 of phi dash. K we know that is 1 minus sin phi dash, and unit weight of water is taken 10 kilonewton per meter cube. So, we have to determine what would be the additional load on the pile due to the negative skin friction. So, this is the cohesionless soil. Okay. So, here the water table is at the ground surface. So, we can use the linear distribution, because if water table not within at the ground surface is some depth below the ground surface, then we cannot use the linear distribution, that will be a bilinear type of distribution. Okay. So, but here we can use the distribution considering the submerged unit weight. So, directly we can use that expression in such case, Fn will be half perimeter into L C square gamma dash K tan delta. Okay. So, K is equal to 1 minus sin phi. So, that will give you 1 minus 30 degree. So, that is 0.5. So, finally, the K n value is half, perimeter will be pi d is 0.3, L C is 2.5 square, unit weight is 18 minus 10, because this is gamma sat, 18 minus 10, then K value is 0.5 into tan delta. Tan delta is 2/3 of phi, which is 30 degree. So, this is the negative skin friction, and that value is 4.3 kilonewton. So, that much of the load, additional load is acting on the pile due to the negative skin friction. So, now I will go to the second case. This is the case number 1. Now, for the second case, case 2, that for the case 2, the problem is slightly different. So, case 2, that we have the field which is this is the field which is cohesionless. And this is normally consolidated soil, this is cohesive. Okay. His properties, this is a soft clay, phi dash is 30 degree, and we have done it for CD test. Gamma sat is 20 kilonewton per meter cube, gamma W is 10 kilonewton per meter cube. Diameter of the pile same as 0.3 meter. The field thickness is 1.5 meter, and total length of the pile is 22 meter. Okay. So, we have to determine the negative skin friction for two cases. One case is floating pile, another case is point bearing pile. Water table is at the fill base level. Okay. So, unit weight of the fill is 18.5 kilonewton per meter cube, unit weight of the this fill. So, first case, that is floating pile, okay. So, we know that here Q 0 value, which will act as a surcharge here. So, that is Q 0 bar, but here the water table is below that fill or the base of the fill. So, Q 0 bar will be equal to Q 0, and that value is 18.5 into 1.5. So, that Q 0 is 27.75 kilonewton per meter square. Now, length of the pile, effective length of the pile will be 22 minus 1.5, because 1.5 is the fill. So, this is 20.5 meter. So, now we for floating pile we know the expression of L1 is developed. So, this is the case where the negative skin friction is due to the movement of the downward movement of the lower soil, that is the soft clay soil. So, L is given L by L1, L by 2 plus Q 0 divided by gamma dash minus 2 Q 0 bar divided by gamma dash, and gamma dash is equal to 10, okay, because gamma dash is equal to 20 minus 10, that will be 10 kilonewton per meter cube. So, if I put L is equal to 20.5, because L is this one is the L, okay, 20.5 and L1 we do not know, that we have to calculate. L is again 20.5 divided by 2 plus Q 0 bar is 27.75 divided by 10 minus minus 2 into 27.75 divided by 10. Okay, again gamma dash is equal to 10. So, we have we will get L1 is equal to 267 divided by L1 minus 5.55, or we can write L1 square plus 5.55 L1 minus 267, that is equal to 0. So, after solving this I will get L1 value is equal to 13.8 meter. Okay. So, L1 value is 13.8 meter, say this is 20. So, 13.8 will be somewhere here. This will be 13.8 meter, and so the neutral point will be here. So, this will be the neutral point, okay, which is 13.8 meter below the field level. Okay. So, I have determined the 13.81 is the L1 value. So, F1 I can calculate, the expression is given, that is the expression, if I integrate that. So, I will get that expression, that is P k tan delta, and then integration of 0 to L1 Q 0 plus gamma dash z to z. So, now if I put the limit, so this will be P k tan delta divided by q 0 dash L1 plus half gamma dash L1 square. So, now I will put this value p is the perimeter which is pi d. So, which will be pi d. So, 3.14 or you can write pi d directly. So, this will be pi d is 0.3, k is 1 minus sin phi. So, 1 minus sin 30 degree which is 0.5. So, tan delta again we are taking the same value 2/3 of phi. Okay. Then q 0 bar 27.75, L1 is 13.8 plus gamma dash is 10, L1 is 13.8 square divided by 2. So, this value is 229. So, 229 is the negative skin friction that is acting in the pile. So, that we have determined. So, now for the case B, which is for the point bearing pile, so point bearing pile L1 is taken as the tip of the pile. So, L1 is equal to tip of the pile. So, for point bearing pile N1 is the neutral point is at the tip of the pile. So, that means the total pile length is giving negative skin friction, but the tip resistance is so high. So, that will counterbalance the negative skin friction, because it is a point bearing pile. So, we can consider L1 as a this case will be 20.5, L1 is the tip 20.5. So, the Fn will be here is equal to pi 0.3 1 minus sin 30 degree, then tan 2/3 of 30 degree, then this will be 27.75, this will be 20.5 plus 10 into 20.5 square divided by 2. And here also in tip bearing point bearing pile also we have neglected the contribution of the tip resistance during the mobilization of the friction resistance. So, this is that is why we can use this equation, or here we can that equation even not required also, whether we consider it or not, that is not mandatory, because we do not need to calculate the L1, because directly we have determined the L1, we consider the L1 as the tip. So, that is not I mean important thing here. So, we can directly put this L1 in the equation of Fn and we will get the value. So, that is 458 kilonewton. Well, this is 229 which will be double, because even if we without putting this value in the equation we can get. So, that will be double, because that is the neutral axis we have considered. So, I mean if the total one is giving the negative skin friction for the tip bearing pile and the for floating pile. So, the equal amount of negative and positive. So, that is why overall this will be almost will be double. So, now I will calculate the last example problem. This is for group. So, we have a group pile of 9 pile in square group. Okay, so, spacing between the pile is 0.9 meter, diameter of the pile is 0.3 meter. So, my B is 2 into 0.9 plus 0.3, that is equal to 2.1 meter. Okay. So, the same problem I have done for the single pile, the same problem that I am taking. So, this problem say, so this problem, so case 1. So, this problem I am taking here for the group pile. Okay, so, for the single pile it was 4.3 kilonewton. So, same problem I am taking here. So, for the single pile, Fn is 4.3 kilonewton. So, Fng is equal to Fs Lc Pg plus gamma dash Lc Ag, that is given. So, Pg is 4 into 2.1 here, that is 8.4 meter, Ag is 2.1 square. So, that is 4.41 meter square, and Fs is, we are taking that same value, because here Fs is the friction resistance, and then now we can draw in linear fashion. So, Fs will be, suppose this is your Lc. So, Fs contribution without perimeter and the length. So, that is nothing but that this is your gamma dash into Lc, this is your gamma dash into Lc. So, it will act at the middle. So, average we have to take. So, average. So, you can take this is 0 plus gamma dash into Lc. So, that is acting at the average middle into K into tan delta. Okay, that is the total resistance Fs. So, if I get this value and take this case, delta is equal to phi, because the interaction is between soil to soil. So, we can write this value is half into gamma dash is 8, because gamma value was given 8, I think gamma dash is gamma dash is 8. Okay, because gamma dash is 18 minus 10. So, this is 8 kilonewton per meter square, meter cube. Okay. So, gamma dash is 8 into Lc, Lc is 2.5 in that problem, K value is 0.5, and this is tan 30 degree. So, this will be 2.9 kilonewton per meter square. Okay. So, now we have to multiply with that value. So, we can write F n g is Fs is 2.9, Lc is 2.5, Pg is 8.4, plus we are assuming the same gamma within the pile group also, and that is 8 into Lc is 2.5, Ag is 4.41. So, that will be equal to 149.1 kilonewton. And for single pile consideration, this is for block and this is for single. This is equal to 9 into Fn. So, 9 into 4.3, that is 38.7 kilonewton. So, final F g is 49.1 kilonewton, because higher of these two. So, this way we can determine the negative skin friction for the group pile as well as for the single pile for different cases. I have discussed the case 1, case 2, and case 3 is straightforward, which is same as the case 1. So, we can determine that. So, and one thing I want to mention that for the tip or the point bearing pile, the negative skin friction basically influence the bearing capacity of the pile, and for the floating pile it influences the settlement of the pile. So, this is one information. So, in the I have finished the pile under compressive load part. So, in the next class I will start a new topic, that is lateral loaded pile. Okay. Then we will discuss the pile under uplift, and then remaining two topics we will discuss. So, there are 4 topics are basically 3 topics are remaining. One is lateral loaded pile and pile under uplift load. So, these will be combined as one module, and the next module will be the well foundation, and the third module or last module will be pile foundation in difficult soil, mainly foundation in collapsible soil or the soiling and the soiling soil. So, these topics will be discussed during the coming lectures. Thank you.